Hi guys, what's up? My name is Alexandra May B. Hoya. I'm from ECE31 of De La Salle University Dasmariñas, and today we're going to do an experiment entitled The Exclusive OR and NOR Gates for my digital electronics subjects. Let's go! Before we start on our experiment, let's have a little background about the exclusive OR and the exclusive NOR gate. The operations of two-input exclusive OR gate is like a comparator circuit that compares its input bits. If the input bits are alike, the output is logic 0. And if the input bits are not alike, the output is logic 1. This is the logical symbol of two-input exclusive OR gate. The exclusive OR gate of two bits A and B can be expressed in Boolean expression as like this. The expression above can be read as A XOR B. The logical input of two-input exclusive NOR gate is the complement of XOR gate operations. This is because of the bubble affixed in the output side of the gate as shown in this figure. The output of XNOR gate is logic 1 if both inputs are alike. Otherwise, the output is logic 0. The Boolean expression of two-input XNOR is expressed like this. Here are the materials and equipment used for experiment 3, the exclusive OR and exclusive NOR gate. 1-piece 7408 ON gate, 1-piece 7486 quadruple 2-input exclusive OR gate, 1-piece 74266 IC, 2 pieces LED, a breadboard, 5-volt power supply, 12-volt power supply, 2 pieces 360 ohm resistor, 1 piece relay, 1 piece 1N4001 diode, 1 piece 2N3904 transistor, a VOM or multimeter, 1 piece 12-volt DC motor, and connecting wires. Part 1. Examining the basic operations of XOR gate. This is the circuit diagram of a XOR gate. This is how you can construct the circuit diagram for a XOR gate. When connected to a 5-volt power supply and inputs A and B are both 0, output is 0. When only B is 1, output is 1. And when A is 1 and B is 0, output is still 1. But when both A and B is 1, output is 0. From the results of the XOR gate, it is observed that it is a digital logic gate that gives a true or 1 or high output when the number of true inputs is odd. An XOR gate implements an exclusive OR, that is, a true output results if only one and only one of the inputs to the gate is true. If both inputs are false or 0, or both are true, a false output results. XOR represents the inequality function. The output is true if the inputs are not alike, otherwise the output is false. One way to remember XOR is that it must have one or the other, but not both. Part 2. Examining the basic operations of XNOR gate. This is the circuit diagram of a XNOR gate. This is how you can construct the XNOR circuit. The result for XNOR gates show that when both inputs A and B are 0, output is 1. When B is 1 and A is 0, output is 0. And when A is 1 and B is 0, output is 0. And when both inputs A and B is 1, output is 1. The XNOR gate, as observed from the results of the experiment, it is a digital logic gate whose function is the logical complement of the executive or gate. The two-input version implements logical equality, behaving according to the truth table to the right, and hence the gate is sometimes called the equivalence gate. A high output results if both of the inputs to the gate are the same. For part 3, single direction DC motor control. This is the circuit diagram for the single direction DC motor control. This is how you can construct the single direction DC motor control circuit. First, make sure you have placed the materials like this. And then let's go to the connection of the wires. After successfully constructing the circuit onto the breadboard, we are now to connect the 5 volt and 12 volt power supply. In my case, it's already connected. I'm just going to turn on the extension wire. So I'm going to turn on the extension switch now. So if I'm to connect A and B to 0, let's observe that output is 0. And if I'm going to connect B to 1, it's observed that output is 1. So now I'm going to connect A to 1 and B to 0. It's observed that output is 1. And if I'm going to connect both inputs A and B to 1, output is 0.
It was observed that the circuit construction for single-direction DC motor control show that it has the same output as the XOR gate circuit. This means that it is also a digital logic gate that gives a true 1 or high output when the number of true inputs is odd. It implements as exclusive OR that true output results if one and only one of the inputs to the gate is true. If both inputs are 0 or both are 1, then a false or 0 output results. The circuit for single direction DC motor control, like the XOR gate, represents the inequality function, which means that the output is true if the inputs are not alike, otherwise, the output is false.
Part 3.2 Applications Half Adder. This is the circuit diagram of a half adder circuit. This is how you can construct the half adder circuit. The results of the half adder circuit show that when both inputs A and B is 0, output is for S and C is 0. But when B is 1 and A is 0, S is 1 and C is 0. When A is 1 and B is 0, still S is 1 and C is 0. But when both inputs A and B is 1, S is 0 and C is 1. The results from the half-adder experiment show that the combinational circuit half-adder is used to add two binary numbers of 1 bit each. In simple words, we can say that it adds two binary numbers of 1 bit each and generates the output as the sum and carry. Also, it is clear that adders perform the addition of bits, but half-adder can only add single bit numbers. Therefore, if you are to add more of a single bit, full adders are used.
This experiment resulted for the understanding of the basic operations of two-input exclusive OR (XOR) and exclusive NOR (XNOR) gate. The results of the experiment in the applications of XOR gate showed how the rule can be applied to a circuit that we might encounter in our everyday lives. The general rule that was observed in this experiment is that for an exclusive OR gate, output is high if the input logic levels are different, and for an exclusive NOR gate, output is high if the input logic levels are the same. The experiment is quite easy to perform and is doable at home since I was able to buy all the needed materials and equipment. I would recommend that before doing the experiment, one should make sure to understand the circuits in the experiment, especially the circuit for the applications. This is essential to be able to successfully achieve the expected procedure and results in a less consuming